الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل.
اوكي السلام عليكم everyone. ان شاء الله تكونوا بخير وان شاء الله تكونوا بصحه جيده. معكم again Taha Rehah. I'm expert ML trainer at Bamboo Geeks and I'm a data engineer at DBMS. So I'm back to you guys with a new session. ان شاء الله المره هذه we are changing a little bit the topic من ال ML from machine learning AI deep learning. We are focusing more on the Google Cloud platform. And I'm going to be trying to focus more on the path to get Google Cloud Platform professional data engineer certified, or like mostly we're going to be inshallah focusing على أي حاجة متعلقة بالدata في Google Cloud Platform. So in this series ارتأيت أنه نبدأ بأول سيشن تكون عندها علاقة بالdatabase management services وإلا databases بصفة عامة، على خاطر GCP is offering a lot of options in terms of databases. We can choose from Cloud SQL, Cloud Spanner, BigQuery, Cloud Bigtable, Firestore, like plenty of databases that Google Cloud Platform does offer to us. أما الصعب فيهم ولا الحاجة اللي صعبة في هي حاجة مزيانة على خاطر عندنا lot of choice. أما الحاجة الصعبة أنه ساعات we as developers ولا as data engineers يصعب علينا أنه نختاروا which service أحسن use case بتاعنا. So هذاك علاش من أصله موجودة path of professional data engineer، وهذاك الجو نتاع professional data engineer certificate أنه تخلي وتخرج لنا engineers قادرين ولا capable أنهم يختاروا right service بالنسبة للright application in the right place. Okay, so let's start. So for today's session إن شاء الله راح نحكيه في الأول على storage في GCP in general، نحكيه على different types of storage الموجودين عندنا. بعد إن شاء الله راح نحاولوا نحكيه بعجالة على الفرق ما بين relational والنو سيكول ولا السيكول والنو سيكول concept. على خاطر in GCP we have two types of databases, relational databases and NoSQL databases. So we have both. We need to understand the concept نتاعهم ساعة، بعد نجمو نمشيو نحكيو على services. So كأول services راح نحكيو عليهم هما relational databases الموجودين في ال GCP واللي هما الكلاود سيكول والكلاود سبانر. بعد راح نحكيو على NoSQL databases اللي هما الكلاود بيج والكلاود فايرستور. ومن بعد نحكيو على analytical databases اللي بصفة عامة راح نعملوا introduction لجوجل كلاود بيج كويري. أما بما أنه بيج كويري هي واحدة من التولز اللي تستاهل بصراحة سيشن وحدها. next session إن شاء الله راح تكون معمقة على البيج كويري. اليوم راح just نحكيو على introduction about BigQuery as an analytical database، وإن شاء الله السيشن اللي من بعد هذه راح تكون معمقة أكثر or dedicated to Google Cloud BigQuery database. So to talk about storage in GCP, we have multiple choices as I said. عندنا managed service يتقسموا ساعة اثنين، يتقسموا للmanaged services والserverless services. بالنسبة للmanaged services عندنا Cloud SQL اللي هي relational database راح نحكيو عليها شوية بعد، Cloud Spanner اللي هي also relational database، وعندنا الكلاود بيج تيبل اللي هي NoSQL database. هذوما 3 types of storage يندرجوا ضمن الكاتيجوري of the managed services. ما معناها managed service؟ معناها Google is doing everything for you. Google is managing the servers, is managing the installation, managing the security, managing the updates. أي حاجة literally متعلقة بالinfrastructure Google is managing it. في الأذر هاند عندنا some serverless services اللي هما الفايرستور كيما الكلاود ستورج اللي هما as like the concept of serverless معروف جدا في الكلاود اللي هو أي service ما يسحقش an server running on the background. مثلا بالنسبة للكلاود سيكول كلاود سبانر وكلاود بيج تيبل هما managed yes صحيح، أما في الانفراستراكشر ولا behind the scenes we have servers that they are running on the background. So we have إما PostgreSQL ولا MySQL مثلا بالنسبة للكلاود سيكول running في واحدة من السيرفيس of Google Cloud Platform. أما بالنسبة للكلاود ستورج وكلاود فاير ستور، كلاود ستورج كما جوجل درايف. كلاود ستورج تحط عليه الفايلز نتاعك inside a bucket نسميوها باكيت عبارة folder inside جوجل درايف تحط فيه الفولدرز بيكتشرز فيديوز اي حاجه تحب عليها تحطها في وسط الكلاود ستورج. الفاير ستور زاد يشبه شويه الكلاود ستورج اما هو معمول للسمول سايز الداتا، معناها داتا اللي السايز تاعها صغير وتستحق كوميونيكيشن ولا تستحق ريكويستس كثيره. وواحده من الاستعمالات العميقه والاستعمالات المعروفه جدا بالنسبه للفاير ستور هي الموبايل ابلكيشنز. So mobile developers mostly they store their data وسبيسيفيكلي data اللي عندها علاقه بالكاتش اللي عندها علاقه بالكوكيز عندها علاقه like some pretty much small data ولا حتى sometimes big data it's gonna be stored في الفاير ستور للعديد من الاسباب راح نحكي عليهم ان شاء الله also today's session. Also عندنا فرق اخر ما بين كلاود سيكوال كلاود سبانر وكلاود بيج تيبل والكلاود ستورج والفاير ستور، انه في الكلاود سيكوال والسبانر والبيج تيبل هذوما they are allowing us to store data or numerical data or tabular data. So basically مثلا عندك database نتاع e-commerce you need to store user ID, client ID, product ID, product name, product quantity. حاجات هذوما الكل راح تستعمل واحده من الداتابيز هذوما على خاطر they are databases. اما كلاود ستورج it's not a database, it's a storing service اللي كما قلت لكم كما درايف. So if you have an e-commerce website وين راح تعمل ستورج نتاع الايميجز نتاعك والفيديوز نتاعك راح تعملها في الكلاود ستورج. اما راح تعمل لينك بين الكلاود ستورج والكلاود سيكوال مثلا باش انه في كل رو مثلا of the product in the product table راح تعمل product ID, product name, product quantity, then product image مش راح تكون في الكلاود سيكوال راح تكون في الكلاود ستورج. So you only put the link there to access it. So هذه الidea انه we have two different storing types. Either if we are going to be storing tabular or numerical or categorical data في وقتها نستعملوا three services اللي على اليسار. وإذا حبوا we store unstructured data we can store like files وإلا images ولا videos في الكلاود ستورج وإلا في الفاير ستور. So مهم جدا تعرف your data in which service it's going to be represented in which way. So إذا your data موجودة في الكلاود ستورج اللي هو here اللي هو serverless it's a serverless server. إذا موجودة في الكلاود ستورج معناه أنه it's an object و stored in a bucket. مهم جدا نعرف technical words هذوما على خاطر if you want to get if you want to go on the path of data engineer professional data engineer in GCP like all of those terms you are going to be like supposed to know them. So أي حاجة أي object stored in أي file stored in cloud storage is called an object. والبلاصة اللي الفايل هذاك stored فيها while is residing in it it's called a bucket. So a bucket can hold multiple objects. If your data is stored in data store or fire store, so in this case we are no more dealing with objects but we are dealing with properties, and each property is contained inside an entity, and entity is is in a kind category. So بالنسبة data store ولا fire store we talk about properties اللي هما الفايلز the end of آخر العقود. Then we have the entity عبارة على bucket وإلا عبارة على an amount of properties like a group of properties. Then we have the kind is a group of entities that they do have the same characteristics or they do have the same properties. So مثلا if we have a user is an entity and the user has the name, first name, last name, phone number, etc. Those are entities. And we have maybe another entity called staff has staff ID, staff name, staff department, etc. But they are having the same or they are sharing the same properties with user. So user and staff we can call them a kind. Those are a kind. If your data موجودة في الكلاود سيكوال ولا في الكلاود سبانر عبارة على your data موجودة في MySQL ولا في Postgres ولا في SQL Server, it's gonna be stored in a value way. So we have rows, we have columns, then we have values. rows and columns معروفين بهم relational databases اللي هما كيما الكلاود سيكوال كيما البوست جريس كيما الماي سيكوال ولا كيما سيكوال سيرفر. Just a very quick tip. It's always very good to know how your data is stored. معناها مهم جدا تعرف الطريقة اللي الداتا نتاعك is stored بها في سيرفيس معين. علاش؟ على خاطر it's gonna be help you to optimize storage والcost or pricing of your data. So if you wanna access your data very often, maybe Cloud Spanner is going to be better than Cloud SQL. Maybe انك تحب data نتاعك تكون rows and columns, so you are going to use Cloud SQL instead of Cloud Data Store. Maybe you want your data to be an entity and a kind, so you are going to be using Data Store, etc., etc. So it's always important and good to know how the data is stored. So خلينا نبداو باول سيرفيس معنا اليوم اللي هو سيرفيس عنده علاقه بالريليشنال داتابيزز. وكتذكير ولا ريفريشر صغير للريليشنال داتابيزز، اي حاجه اي داتا so like relational databases do require دائما structured data. They need to always have structured data. ما معناها structured data؟ انه we need like a user مثلا كيما الاكزامبل تاع الاي كوميرس. So an e-commerce database has a users tables فيها user name, first name, last name, address, phone number, etc. Then عندنا another table اسمها product فيها product ID, product name, product last name, etc. etc. So هذا ما يصطلح عليه هو what do we call a structured data, which means it does have a fixed schema. ما معناها fixed schema؟ معناها we have one architecture. معناها we know that table user عندها معها table product معها table command انه نعرف انه كل يوزر ينجم يكون عنده or can buy multiple products, and each product can belong to multiple commands at the same time. So ده ما يصطلح عليه بالstructured data, and the language that is being used to interact with this structured data is called SQL or Standard Query Language. So those relational databases, we have many of them inside GCP, or we have many offers of them inside GCP that we are going to be talking about very soon. But before it, I want to mention that we have like two types of databases that they are. First one, relational. كما حكيت لكم, we have like as an example here posts and comments. But we also have non-relational databases وإلا NoSQL databases. The difference between relational and non-relational is that relational is mandatory to have a structured data and a fixed schema. On the other hand, non-relational databases they don't require أن يكون عندنا a fixed schema, و they don't require أن يكون عندنا a structured data. معناه أنه inside a non-relational database I can store the post, the ID of the post, the title, the comments, and I can store also the image of the post. I can store the voice, I can store the video, I can store like a string along with a number along with an image. So non-relational database معناها انه I'm not following any structure. Like if I receive a data نحطها في my database بطريقه اللي نحبها ليها انا. But I can receive another type or a new schema as you can see here في example تاع posts. I receive sometimes البوست والتايتل مع الكومنتس, و sometimes I receive البوست ID and عنده title اما ما عندوش comments عنده image. So which means I don't have a fixed schema. This is not possible in relational databases. في relational لازم عليا انه نحط same type, مش same type اما same structure. I need to have a structure. مثلا here each post has an ID and has a title, but if it has a comments I can't here put all the comments معاه في نفس الrow. لازمني اصنع a new table اسمها comments اللي عندها direct relation with posts, ومعناه انه كل post each one unique post can have between 0 and n or have as many as he can of comments. بطريقة هذه I'm like sure that I'm always following a certain structure, but here I can break this rule and I can like use unstructured data with non-fixed schemas. بالنسبه للريليشنال داتابيزز السيرفيسز الموجودين في السيرفيسز الموجودين في الجي سي بي واللي تابعين يتبعوا or they are following the relational database model or concept. First one, most famous one, is the Cloud SQL. Cloud SQL, again, it's a managed service. It's not a serverless service, it's a managed database service that is being used when, like, first obvious thing, when you need a relational database. معناها when you have a data that can be stored in a relational database. That's the very first condition. Which means انه عندك a structured data, عندك a predefined schema, and you need strong consistency. علاش strong consistency? Because it's well known that any relational database and any like type of or relational database management system is offering to the developer or to the user a strong consistency when it comes to querying, when it comes to relations between tables, when it comes to like retrieval, insertion, deletion, etc. So if you need those, or if you have follow those requirements and those criteria, then تستعمل or you can choose Cloud SQL, but within some limits. Is that Cloud SQL هو a regional data store. It's a regional data store. It's not a multi-regional data store. معناها أنه when you create a Cloud SQL server, it's going to be limited inside one region, but with multiple zones, yes. But let's take an example that your Cloud SQL cluster is being deployed on North Europe. So which means that your cluster can only be on North Europe, but it can be like available in multiple zones like North Europe A, North Europe B, or C, but it cannot be available, not available, but it cannot be deployed on other regions like West Europe or North US or West US, etc. ما معناه, which means أنه if you have users coming from North Europe, it's going to be fine. If you have users only coming from North Europe, it means that like it's gonna be fine because they are going to be retrieving the data from North Europe, and we are not going to be experiencing a latency of retrieval or any errors, any major errors. But when you have like users from North Europe, from North US, from South Africa, from like MENA region, etc., it's gonna be hard. So you need to like take or pay attention to this, because if you need data that needs to be cross-region or multi-region, then Cloud SQL may not be a good service for you, might not be a good thing to choose. Also, Cloud SQL can support only up to 30 terabyte per database. So Cloud SQL هو يخدم بconcepts of virtual machine or of servers, and each unique database on Cloud SQL or its database instance from Cloud SQL can support 30 terabytes of data, which is not something like that is very small. 30 terabytes is like a big scale. It's a company, it's an enterprise scale level. But if you know, or if you have a bigger database, then Cloud SQL is not going to be the good choice for you unless you scale horizontally, which means you add a new Cloud SQL instance. Also, Cloud SQL is limited when it comes to DBMSs, because Cloud SQL, as I told you, it's a managed service, and it uses one of the following database management systems, واللي هما most famous database management systems in the development ecosystem, اللي هما Microsoft SQL Server, Postgres, and MySQL. So the thing is, Cloud SQL is deploying instances from those three database management systems or services, which means that when you go to Cloud SQL, you want to create an instance from Cloud SQL. The UI tells you which database you want to use. So do you want to use Postgres or MySQL or SQL Server? It is exactly like the way you are going to go and go to a server, then go and sudo apt install, apt-get install Postgres, then configure the ports, configure the firewall, configure the password, the users, the databases schema, etc., etc. So instead of doing all of this, Google Cloud SQL is going to be going or implementing واحدة من السيرفرز من ال database management systems for you, and you only care about accessing it So you don't care about security, about updates, about what's happening on the background, but you only care about accessing the database and modifying the tables, modifying the schema, modifying the values, etc., etc. So هو في ظاهره it's just like a normal database, but on the background it uses either, you need to choose either Postgres, MySQL, or SQL Server. So if you are more familiar with Postgres, go ahead and use Cloud SQL for Postgres. If you are more familiar with MySQL, go and use MySQL. Then if you are familiar more with Microsoft SQL Server, you can go ahead and choose Microsoft SQL Server. This is the hierarchy, or this is the model of how Cloud SQL instances are working. So basically, كما قلت لكم في background, it's a virtual machine. As you can see here, it's a virtual machine. That inside the virtual machine, we have an operating system, obviously. And inside the operating system, we have the database installed. مثلا Postgres. So we have a virtual machine that we don't manage. It's a managed virtual machine that was created by Cloud SQL. By the way, when maybe you are not doing a demo اليوم, if you go and try by yourself to create, you try to create a Cloud SQL instance, you are going to be seeing that you are going to be having a new VM created on the compute engine. And it has a random name with a random ID, but that virtual machine cannot be accessed من عندك انت, can only be accessed by Cloud SQL service. So the idea انه inside operating system عندنا database installed along with other logging and monitoring and other services to just try to log, monitor, see what's happening on the database. Then each virtual machine or each operating system هو linked with a persistent disk اللي كما قلنا السايز نتاعو maximum 30 terabytes. All of this is going to be given or going to be linked to a static API, a static IP, sorry, so a static IP. That is the one that is you are going to be using to connect to your database. So when you choose مثلا Cloud SQL instance for Postgres, you are going to be receiving an IP like 127.1.1.2, and that static IP is going to be the IP of your database, but not the IP of your virtual machine. So if you want to access other things inside the virtual machines, you are probably not going to be able to do this. But the only thing that you can do with that IP is to access the database. So that's why we call it managed service. That's هذه definition تاع managed service. Then maybe السؤال اللي يجيك لراسك الآن ولا maybe the question that you are asking yourself now is, what is the difference between me as a developer and I go and I create a server, I create my own server, then I go ahead and install Postgres, install MySQL, then configure the users, configure security, configure firewall, etc., etc. What I'm gonna gain if I go to Cloud SQL and I let Google do everything for me. So let me say that you are going to be gaining data protection. What is data protection? And how to say it, with all the experience or with all the things that you are going to be doing to protect your data, you cannot reach out the level that GCP is going to be doing for you to protect your data for you. So it's gonna be the job of Google to protect your data. So that's the very first thing. That's for me the most important thing to use a managed service. And by the way, now in 2022, and we are going further with the utility of cloud. Most of companies now are using cloud, and the strategy of most of the companies is to use managed services, because one of the most important things is that they are gaining is they are no more dealing with infrastructure and they are no more dealing with security breach. So when you have your data on the hands of Google, so Google is going to be protecting your data, and you are going to be only focusing on your developers are going to be more focusing on the schema, on the quality of the data, instead of focusing with the infrastructure or focusing on other things. Second thing, اللي هو data migration. Data migration is also one of the hot topics that data engineers do encounter, which means that you need, when you have to migrate from a database to another one, or we have to migrate from a region to another region, or things like this, it's easier to do this when you are using a managed service than to do it when you are using like your own database server. Also, you have logs, you have a login system that is built in, you have a planned maintenance, you have replication, data replication, you have, as we said, security, and you have insights about your database. So mostly you are just like going to be following and tracking your database, how your database is doing, and if there are any errors, if there are any things that they are not okay. But mostly you are just going to be watching and doing analytics, not managing the infrastructure. Also, Cloud SQL is not, how to say it, is not Google closed. Like, it's not something that if you use it, you cannot use other services from other companies. Like if you use Cloud SQL with Postgres, it doesn't mean that you cannot integrate with a Microsoft web application, or you cannot integrate with Amazon or with on-premise data, other applications. No, it's like free, not free, it's open. So basically, you can integrate with any other services. It's not like limited to Google services. Use some use case examples. We can like cite here content CRMs or IRPs or e-commerce and web applications, or also software as services applications. Like mainly they all use, like we all use say like Postgres or MySQL. We always use them. We always use them for fun. We use them for personal projects, and they are also used on enterprise scale. So basically, many cases can have the use of Cloud SQL, since we are always using those databases. Okay, so now we are done with the Cloud SQL service. I don't know if you have guys any questions. Please ask me on the comments. Next service, واللي هو also under the relational databases services, is the Cloud Spanner. So Cloud Spanner, again, it's a managed service. It's a relational database, which means that if you want to use it, you need to have a relational database use case, which means, again, that you need to have a structured data, predefined schema, and also you need to have strong consistency. But the difference here between Cloud Spanner and Cloud SQL is that Cloud Spanner is multi-regional and also global scale, which means that إذا عندك a big database that needs to be available multi-regional, which means it needs to be deployed on North Europe, on West US, and on North Asia. And it's also global scale, which means you have petabytes of data, or like you have a big amount of data. Then Cloud Spanner is going to be the answer for you. It's globally distributed, which means you can have nodes, or you can have, because the Cloud Spanner is working behind the idea of not like it's not working with servers, but it's working with clusters. So basically, it's globally distributed, which means we have nodes in each region. It's highly available. The cluster is always highly available. We can go with up to 2 terabytes per node. So each node can have 2 terabytes, and the cluster can have as many nodes as you can. So you can scale up very quickly in an horizontal way. Also, it does support automatic replication, and there is no planned downtime. So please underline this. There is no planned downtime, which means that your database is 100%, or let's say 99.999% available, always available. There is no downtime. And that's because of the replication and of the multi-regional. So which means that if a region is down, the other region probably is not down. So your data is not going to be down, and your users are not going to be affected. And again, it's using SQL. It's using the structured query language. So it's not something that is weird for us. It's like handling Postgres or MySQL. The difference is that Postgres is using like, or MySQL is using their own DBMS. Postgres is also using their own UI. Cloud Spanner is running on the Google engine, on Google Spanner engine. It's a product of Google, but the interface and the communication is very similar to the Postgres one. So if you are familiar with Postgres, you can very easily use Cloud Spanner. but behind Cloud Spanner, there is no Postgres engine, but there is the Spanner engine. And the Spanner engine was demonstrated that is pretty much faster than Postgres, and it does offer those characteristics that they are global scale, global scalability, and multi-region availability. So again, what do you gain from Cloud Spanner? Is a relational database that is built for scale, which means that it's built for big global scale. It's highly available. There is no downtime, as I told you, 99.999% availability. It does support automatic sharding and automatic replication. It does have a Postgres-like interface, which makes developers very familiar with it, and does not require a lot of time to try or to get. And it's also built on the Google Cloud Network, so that's why it's always available, because it's built natively on the Google Cloud Network, and that's a plus behind. That's why it's always making it on the top, up from the Google Cloud SQL service. Some use case examples can include gaming, so mostly gaming applications or gaming services. They are using Cloud Spanner on the background because it's global scale, for its global scalability and for its high availability, because gaming require high availability and require no downtime. So that's one of the things that's why people from the gaming industry are always using Cloud Spanner. Also, retail services, they also use Cloud Spanner. Since retail, they do have a high scale of, very big scale of databases of data. So that's also it. Maybe also we can have global financial ledgers and supply chain management also using Cloud Spanner. Okay, so now that we covered, let me go back again a bit, that we covered Cloud SQL and we covered Cloud Spanner. Now I said that on the Google Cloud platform, we do have two types of databases, the relational databases and the NoSQL databases. The ones that I was talking about just now are Cloud SQL and Cloud Spanner, and both are relational databases, which means that they are supporting the SQL or the structured query language, and they are supporting structured data. So the idea is that those ones are made for some specific use cases. Now we need to go and discover the NoSQL databases that GCP is offering for us. And our first guest coming from the NoSQL family is gonna be the Cloud Firestore. Cloud Firestore, I think if we have some mobile developers here listening to us, they are going to be happy hearing Cloud Firestore here, or any Firebase users also, they're going to be familiar with Firestore. So Firestore is a document-based database. Now, معناها document-based, which means that it uses the document model and it goes on a key value pair. So if you are familiar with Python or you're familiar with programming languages, you know that we have dictionaries. And the idea behind dictionary is we have a key, then we have a value. So like we have user name, 2 points, then that's the key, and the value is Taha. Like then we have the user last name, so the value is that's the key, and the value is Rehah, etc., etc. So that's the model, or that's the base architecture of Firestore. It goes for key value pairs, and it goes on an hierarchical structure. So we can have key values inside key values, which means that I can have username as a key, then Taha as a value. Then I can have classes as a key. Then I have another key value pairs as a value. So I can have classes. Then I have class 1 as a key, then ML as a value, class 2 as a key, then cloud as a value. All of those are called are key values pairs, and they're called document-based model. So Firestore is based on this. And that's why it's called NoSQL, because there is no structure basically here. And it's not going to be using the structured query language, but here we are going to be querying the key value pairs. using other attribute or using other techniques that they are going to be sometimes faster than using the SQL architecture. So when to use Cloud Firestore? أول حاجة when you have a semi-structured data. So why it's semi-structured, not unstructured data? It's semi-structured because there is a bit of structure in this data. When you have username, when you have users as a key, then you have a list of users with usernames and passwords and IDs and phone names, etc., as a value. That means that there is a certain structure, but it's not fully structured because sometimes I can have no users, because sometimes I can have I can append an image, or I can append a comment or something like this. So it's semi-structured. And when you have this type of data, Cloud Firestore is going to be a good choice for you. Also, when you have a schema that is not fixed and may change over time, so you can very quickly change the schema if you are using Cloud Firestore. Also, Cloud Firestore is one of the very rare services that supports the querying of multiple attributes. I'm going to show you that this with Cloud Bigtable, but multiple attributes is that like you can query at the same time multiple attributes on multiple keys and value pairs, and that is something that is mainly supported only now for inside Cloud Firestore. Also, it's bounded it can be serving or served as a bounded ingestion volume, which means it does support very high read and write requests. That's why mobile developers are using a lot of Cloud Firestore. They're using a lot of Cloud Firestore because it does support very high speed of read and write, and it does support also the querying of multiple attributes. And sometimes on mobile development, the only thing that is going to be making the difference between app A and app B is the fact of supporting the multiple attributes querying feature. Cloud Firestore has a lot of modes, or we can say AKA has a lot of names. So we have Cloud Data Store, and we have Cloud Firestore in Data Store mode. Then we have Cloud Firestore in the native mode. Cloud Data Store is a general available service that is using the Data Store API and is having a kind data model of kind/entities. So it's the same one as the cloud, as I told you like before on the introduction. So we have entities, then we have kinds, and entities and kinds are just like the relation between dictionaries and the keys and values. So we have the key, we have the value, and each key can hold multiple values. Then each value can also serve as a key to hold multiple other values, etc., etc. So an entity has multiple properties, and a kind has multiple entities that they do have the same, that they do hold the same, the same properties. So the idea behind Cloud Data Store is that is supporting the key value pair structure, or AKA the document model database, but it does not support real-time updates, does not support offline data persistence, and most more important thing is that it doesn't support mobile or web client libraries. So it's just like an object or a cloud storage that is going to be helping us to store objects. Now, on the other hand, we have Cloud Firestore in its two modes, in the native mode and in the data store mode. So Cloud Firestore in data store mode is equal to Cloud Data Store. There is no difference except that cloud data users are having very strong query consistency, and it's still on the beta stage, not like generally available yet. The most important thing now is the Cloud Firestore in the native mode. That's the thing, the most used thing by mobile and web developers. So that's why they are always saying Firebase, and Cloud Firestore. They are always using Cloud Firestore in its native mode because it does support not kind entities data model, but it supports collections and documents. And the document model is inspired also from kind entities, yes, but it's more consistent than kind entities. And also, it does support real-time updates, which means very quick with zero latency updates. It also supports offline data persistence. That's why mobile developers loves it, because mostly when mobile applications, when you are offline, you still have your data on it. So that's thanks to Cloud Firestore. Also, it does have obviously mobile and web client libraries that they are letting developers interact with mobile languages or mobile frameworks as much as they can interact with the web or web client libraries. Yeah. Okay, so that was for the Cloud Firestore, which is, as I said, a document-based database or document model database. Now we are going to be moving to Bigtable, which is also a NoSQL database. So just like a refresher, حكينا على or we talked about the Cloud SQL and the Cloud Spanner, which both are relational databases services on Google Cloud Platform. Then we mentioned Cloud Firestore, which is a NoSQL database that is based on the document model. Now we are talking about a new service called Cloud Bigtable, and Cloud Bigtable is a wide column-based database. So it may be confusing for you guys that we have so much database services on the Google Cloud Platform, but it's something that is very good because it helps or it makes the developer feels free to use or to that the developer have many choices that he or she can use in order to build a better optimized application and understand more him or her data very very quickly. So قد نقول انه Cloud Bigtable it's a wide column model based database. والفرق انه the difference is with relational databases we were based on tables. We were like mainly requiring tables and views, etc., like anything related to SQL. Then with Cloud Firestore, we were requiring documents. We were based on the key value pairs. Now with Cloud Bigtable, we are based on something that we call the multi-dimensional sparse data model, which is just like a sort of matrix that is multidimensional matrix, and in each step or in each matrix inside this big multidimensional matrix, we are going to be storing few data. And that's why we call it sparse. Sparse, which means that it's mostly empty, it's mostly having zeros, but the idea of it is that we are filling multiple matrices and we are holding few amount of data inside each matrix. In that way, we are optimizing the query time, or we are optimizing the storing or the retrieving time from the database. So let me make it more clear for you. That's what we call a column-based or a wide column-based model. So as you can see here, we have, it may look for you guys as like a normal SQL database, relational database, but actually it's not. And you can see here the difference is here. Basically, we have here rows and columns, which is like something that we call which is very normal for SQL and relational databases. But the difference is that in each column here, on the wide column-based model or on the BigQuery storage model, we can hold multiple types of data. So as you can see here in this column, I can hold an array of data that is T1, T2, T3, and T1 also can hold other values, etc., etc. So that's why it's NoSQL. That's why it's called wide column-based, which means that each column can hold a wide amount of data on it against it's not like only X and Y, but now we only have Z. So the Z is why it's called wide column, and which means that it's allowing us in each case or in each data placement, we can hold multiple values or we can hold multiple types of data. Yes, so that's like a schema to show you guys the difference between all of the models that we talked about. So we talked about the key value. Remember, we talked about the key value pair, which is the case for the NoSQL databases. Also, the documents model, which is the case of the Cloud Firestore with the native mode, and the key value for the data store mode. So data store mode is using key value, and native mode is using the document model. Then we have the column-based model, which is common for relational databases, but also for no SQL databases, as we saw an example of Cloud Bigtable. And then we have also the graph database, which is something that is new, and also it's so much performant. And I think like now Google on 2022 launched a new database that's still on the preview stage that is supporting graph database. I'm not pretty much sure about this, but maybe if it's launched, we can have a session holding talking more about the graph database. This is just to show you guys the difference between the logical schema and the row-based storage or column-based storage. So here we have a normal logical schema that we have the employee number, last name, the job, and the MGR. If it's row-based storage, if we are using the row-based storage, which means that each row is acting as one specific or one unique piece of data. And when we are dealing with column-based storage, it's just like a switch. Now, instead, in each row, we have the employee number, the last name, the job, and the MGR number. Now, with column-based storage, in each column, we have those information. So in each column, we have the last name, the job, the employee number, then we have the MGR. And in each row, we have one type of properties. So you can see here that all in this row, we have all the names. Then here we have all the jobs. Then here we have all the MGR numbers. Then here we have all the employee numbers. The difference between those two things is on, or like when to use column-based or row-based storage. It depends on what type of data you want to store and how you want to query it. Because sometimes querying the column is easier or it's faster than querying the row. Because sometimes you only need analytical information. So you only need information about how many names do you have, how many jobs do you have, what are the unique jobs, etc., etc. So in this case, column-based storage is going to be better than the row-based storage. Row-based storage is used for transactional databases mostly, when I need to know, like, or when I need to get all the information about the user, I need to update the information about the specific user, etc., etc. It's going to be fast than doing this with the column-based approach. Yes, so here, just like guys, to show you that in each column we can store multiple data, and this also Bigtable is supporting a concept of column families. Column families is a concept that helps query be more faster, which means that when we have columns that they do have or they do serve to the same objects, we group them inside the same family. So you can see here the family of description is having two columns called title and department. Then another family called metadata does hold information about the last update and the author. So those are two different families, but inside each family, we have the columns that they are going to be defining that family. So when the query is about only description of the user, I'm not going to be retrieving the last update and the author, but I'm going to only be stuck to the title and the department. That's a very huge difference between making a very huge difference on the time of the execution of the query. So the idea here, what do you gain from Cloud Bigtable, is you gain an incredible scalability. Cloud Bigtable, as of its name, it's big, and it's only being used for petabytes or exabytes scale databases, which means that when you have a very huge amount of data and you want to store them in a NoSQL model and in a wide column-based model, then Cloud Bigtable is the right choice for you. Also, it does come with a simple administration and a very simple cluster resizing without any downtime, as like the Cloud Spanner service. Some use case examples of Cloud Bigtable does include time series data, marketing data, financial data, IoT, graph. You can see here all of those examples. They do require, they are big, they do have big scale of data, and they do require a NoSQL model with a high availability and low latency. That's why Cloud Bigtable is always killing it when it comes to financial data, when it comes to graph data, or when any type of data that is like requiring low latency and high amount of data. Then by the end of by the end of the all the services, we have the you can say الأخت الكبيرة, or the coup de cœur, as we say in French, or the best service ever in Google Cloud Platform among the storing and database services, which is the BigQuery. BigQuery is not a database, but it's an analytical database, but mostly it's a data warehouse. It's a database slash data warehouse where it can store, or it can help us to store types of data, but in the goal of doing analytics, not querying normal databases. So BigQuery has a lot of services that we need a whole session to talk about them, but it's something that is very interesting to have. And the concept behind BigQuery is that BigQuery is not using tables and rows and columns, but it's using data sets. And the data set is just like a collection of tables. Each table has normal column row based technology, but a data set, that's why like it's analytical, because but it's optimized for doing analytical queries or for performing analytical queries, and to integrate that with machine learning pipelines, with data pipelines, with other things that we are going to be seeing, inshallah, on the next session more deeply. Okay, guys, so to clear your confusion, I know many of you now could be confused about which storage service I need to use. Like I know all the services that they are in Google Cloud Platform, but which one I need to use, or should I use, and in which case? So this diagram coming from Google is maybe easier, making things easier. So we can start on the starting point here on the top right level with the start on the green, with the green color. So the first question to ask yourself is your data structured? Do you have a structured data? So here, that's the sharpening question. If it's structured, then we have a whole other process. If it's not structured, then directly go to cloud storage. What do we mean by not structured? I mean images, videos, audios, any types of data that is like does not have any types of structure. So in this case, go ahead, please, directly to cloud storage. Now, when your data is structured, we move on and ask the next question, which is, does your workload involve analytics? Do you need to provide analytics to the business team or to inside your workload? If the answer is yes, then you know, guys, where to go. It's either Bigtable or BigQuery. So the difference between them is the answer of the question. Do you need extensive updates and or low latency? If you need extensive updates and low latency, then please go ahead with Cloud Bigtable. Then if you need only analytical, but you don't care about latency, then please go ahead with BigQuery, because BigQuery is going to be supporting the analytical side, but Bigtable, as I told you guys, it has a very high throughput. Throughput is just like the time of read-write and the time of the latency between sending the query and receiving the response. Bigtable is handling big amount of data, but with very low latency and very like close to zero latency. So in this case, you can use one of those two. Then if your workload does not involve analytics, you just like have the famous question. Is your data relational or no relational? If it's relational, you have two options, Cloud SQL or Cloud Spanner. The difference between them is scalability. If you need global scalability, go ahead with Spanner. If you don't need it, go ahead with Cloud SQL. Then if your data is non-relational, it's NoSQL, then you have two options, Firestore, aka Data Store, or Memory Store. So if your application needs caching, then go with Memory Store, because Memory Store is highly available and does store very small amount of data. But Firestore is transactional database. So basically, it's made for transactions to make queries that they are mostly on the normal use case. So the last question here is what to consider when selecting the storage. Please selecting the appropriate storage technology depends on many characteristics or requirements. But please care about mapping storage systems to business requirements. Always think about business requirements, then map them to storage systems, because all storage systems do have their use case that is very clear for business, do your data modeling before choosing the service, then do the discussion about the trade-off about latency, throughput, and transaction. Do you need latency? Do you need low latency or no? Do you need high throughput or no? Or do you need like performant transaction or you need very normal transaction? Also, ask yourself, do you need distributed systems? If you need them, go with Spanner. If you don't, go with SQL. And do your schema design. Always do your schema design before even involving inside things or with any of the services. So to close the session and to end the session, I'm going to be letting you guys see this sketch note from Priyanka, the cloud, aka the cloud girl dev. Priyanka is the chief content officer at Google Cloud, and she is making very, very beautiful sketch notes to make the memory or to make cloud easier. So if one of the sketch notes here, she's talking about which database should I use, which is a very clear thing to always keep on your side, guys. She's like, she has a book that has all the sketch notes, and they are also available on GitHub for free. So please check them, and they are going to be like helpful to choose between relational, non-relational, which relational or which non-relational table. As you can see here, the difference between Cloud Bigtable and Firestore, then the difference between Bare Metal, Cloud Spanner, and Cloud SQL. So yeah, that's it for today's session, guys. I hope it was pretty much clear. We still have a couple of minutes, so please, if you have any question, type them on the chat. I will be happy to answer them. We can wait for a couple of minutes to see if you have guys any question. So if no questions, guys, I would just like remind you to that like the next sessions are going to be all about the professional data engineer certificate. So we are going to be launching a preparation path for it, and I'm going to be including anything about data. So if you have any suggestions and if you have any concerns about the certificate or about the data engineering on Google Cloud, please send me your feedback on taha@bamboogeeks.com. I will be happy to receive it, and I will be happy to communicate to see which sessions you want on this series and which like concepts you want us to cover very, very soon. Thank you very much, guys, for your attention. Inshallah, see you very soon on the next session. Assalamu alaikum.